In this lesson, we're going to have a look at solving simultaneous equations using the substitution method. There are a couple of things we need to take into account when we're using the substitution method. Right? The substitution method is particularly useful when one or both of the equations is in the form where one of the two variables is the subject. Right, so for example, if I have a look at this question here, where they say solve the following simultaneous equations. We've been given two equations. One of them is y equals 2x minus 1. The other one is 3x plus 4y equals 21. Now I can see in the very first equation, it is in the form where one of the variable, which in this case is y, is a subject. So y is equal to 2x minus 1. So what we then do is we take the variable and then substitute into the other equation. Right, so that's what we're going to do in this first example. Right, so I'm going to take the second equation, which is 3x plus 4y equals 29, and I'm going to substitute the value of y into that equation. Alright, so I'm going to replace y with 2x minus 1. So let's start by doing that. So I've got 3x plus 4 times, make sure you use the brackets when substituting, minus 1 equals 29. Now I'm going to expand the bracket to 3x plus 8x minus 4 equals 29. Collecting like terms, so 3x plus 8x is going to be 11x minus 4 equals 29. Now to solve for x, our first step is going to be we're going to add 4 to both sides. Right, if we add 4 to both sides, I'm going to have 11x is going to be equal to 33. And then obviously we're going to divide both sides by 11. Right, and that gives us the answer for x equals 3. Right, so we've found one of the variables. Now we still need to find the value for y. So what we're going to then do is we're going to basically substitute this value. Right, so substituting x equals 3. Right, we can substitute into either of the equations. In this case, it would make sense to substitute in the form y equals 2x minus 1 because that's the easiest way to work out the value for y. So we're going to have 2 times 3, take away 1. So 2 times 3 is 6. 6 minus 1 gives us the value of y as 5. So the simultaneous equation has solutions x equals 3 and y equals 5. Now let's have a look at another example here. Now in this particular example, I've got two equations, y equals 5x minus 8 and y equals minus 3x plus 16. Now in both cases, y is the subject. So both the equations are written in the format where y is the subject of the two equations. So what we're going to do is y is equal to 5x minus 8. Y is equal to minus 3x plus 16. What that tells us is 5x minus 8 is going to be equal to minus 3x plus 16. Now because both of those statements are equal to y, they must be equal to each other. Now we're going to go ahead and try and solve this equation for the value of x. Now what I like to do when it comes to having variables on both sides of the equation, I like to get rid of the smallest one. So in this case, and that smallest one is minus 3x, and the quickest way to get rid of minus 3x is going to be adding 3x to both sides. So we're going to add 3x to both sides of the equation. 3x to both sides is going to give us 8x minus 8 equals a positive 16. Now we're going to go ahead and solve this equation for x. So the next step is going to be add 8 to both sides. So I'm going to add 8 to both sides, leaving us with 8x is equal to 24. And one final step in solving for x, we're going to divide both sides by 8, leaving us with the solution as x is equal to 3. Right, now that we've worked out the value for x, we still need to find the value for y. Now in this question, it doesn't matter which equation we substitute into because both the equations have y as the subject. So I'm going to go ahead and substitute x equals 3 into the equation y equals minus 3x plus 16, right? So I'm substituting x as 3, so I'm going to have minus 3 times 3 plus 16, right? Which gives us minus 9 plus 16, leaving us the solution for y as a positive 7, right? Now the quickest way to check if your answer is correct is by substituting both the values into the equations. If I substitute x as 3, I'm going to have 5 times 3, which is 15. 15 minus 8 is equal to 7, and that proves me that my answers are correct for this particular question. Now one final example in today's lesson, right? We're going to have a look at a slightly complicated question in this case here. So I've got two equations, minus 3x minus 2y is equal to negative 12. And my second equation is y equals 5x minus 20 divided by 3. Now the second equation is obviously in the form where y is the subject in this particular equation. So that's what we're going to substitute into the other one. So we're going to substitute the value of y into that equation there. Right? The only complicated issue here is obviously the y is equal to, the equation of y equals is in the form of a fraction. That's the only complication in this scenario. So let's go ahead and substitute. So when we're substituting into the first equation, we got to make sure we include a bracket when we're substituting. So 5x minus 20 over 3 in the form of a bracket equals minus 12. Right, I'm going to go ahead and first expand the bracket. So I'm going to have minus 3x. Right, when I say expand the bracket, we are basically multiplying the terms inside the bracket with a minus 2. So leaving us with minus 10x plus 40. Now the whole thing is going to be divided by 3 equals minus 12. Right, now what we notice here is we've got three terms, all of them having different denominators, right? The lowest common multiple, the quickest way to get rid of a fraction in any equation is to multiply the whole thing by the lowest common denominator. So in this case, the lowest common multiple is going to be a positive 3. So I'm going to start off by multiplying the whole equation with a positive 3. Right? So let's do that. So if I multiply the whole equation by positive 3, I'm going to start by getting minus 9x. Now, when I multiply this fraction by a positive 3, the 3 is going to go into each other once, leaving us with minus 10x plus 40 equals minus 12 times 3 is going to give us minus 36. From this point onwards, the question becomes quite straightforward. Right, we're going to start by collecting like terms, giving us minus 19x plus 40 equals minus 36. Right, solving for x, we're going to do minus 40 on both sides. Right, when we do minus 40 on both sides, gives us minus 19x is equal to minus 76. And one final step in solving for x, divide both sides by minus 19. Gives us the solution for x as x is equal to a positive 4. Right, now that we've worked out the value for x, we still need to work out the value for y. So in this case, I'm going to substitute the value of x into this equation where y is a subject. Right, so let's start by doing that. So the equation we have is y equals 5x minus 20 divided by 3. So I'm going to substitute the value for x as 4. That's going to give me 5 times 4, take away 20 divided by 3. Now 5 times 4 is 20, so 20 minus 20 divided by 3. 20 minus 20 is 0, and 0 divided by anything is simply equal to 0. Right, so the solution for this particular question is x is equal to 4 and y equals 0. Alright, so like I mentioned to you earlier, the only complication in this particular question is the fact that we are substituting in the form of a fraction. Alright, and as long as you can deal with the fraction, the question becomes quite straightforward. Right, that will be the end of our today's lesson. Thank you for listening and have a wonderful day.